Today we're going to cover how to work with position registers and also some other miscellaneous instructions that we'll cover. So that includes how to apply position register instructions. We'll look at the position register elements, the I and J components, and we'll also look at position register offsets and how we can use those in motion instructions. So position register instructions within programming are found in your instructions menu. Position register instructions have several different options. We have position registers that can be identified both by the group number that they apply to as well as their numeric identifier, which can be either direct or indirect addressing. Within that instruction, we can make that position register equal to a linear position, a joint position, the tool frame, user frame, position register, or position. So remember, a position register is really just a register that has multiple components to it. And within that, we can save all 6 identifiers for a coordinate system. So an LPOS is looking at the current position of the robot and then saving that to the position register. Or we can also look at the joint positions of each joint and save that. We can do the same thing with user tools, user frames, which again use the same components as a coordinate system, where we have an XYZ and a WPR to identify its orientation and position, as well as we can make it equal to another position register or just a position. Within that, we can also do some algebraic operators in terms of addition and subtraction. So we can add what we save to that position register to another, either another position or position register or the LPOS and JPOS. Position register element instructions manipulate a specific position register element. A position register element is one element of a specified position register, where the designation I represents the position register number, and we can refer to that either directly or indirectly with a register that then points to a numeric value. J represents the position register element, which can be either representative of a Cartesian position or a joint position. So in the program shown below, in this example, we have a position register which is equal to the linear position of the robot at that time. We take an element 2, which would be the y coordinate of that position register, and we overwrite that with the value of 600. The next linear move moves to that position register, which is now going to have that new y value for its coordinate. So that y value is going to overwrite whatever value was there before and will continue to remain with that position register until another value is written into its place. So one way we can use position register is to offset a home position or recovery position so that we don't have something like this happen with our robot. That would be bad. So in this example, we have a robot that we want to send home. However, it has an obstacle in its path. We've got to figure out how to get around that. A way to do that is to take a position register and equate that to the linear position of the robot at that current time. We can then take an element of that position register, the one that we're interested in. In this case, that would be the Z component. And we can look to see if it is above or below a certain threshold that allows us to know that the robot is in a safe position in order to move home. In this case, we identified that the robot is not in a safe position, so it does not jump to that label 2. Instead, it rewrites to the position register a new value that then allows it to move to a safe position along the Z axis. And then we can move the robot to that position register with the new Z value to a safe Z height, and then allowing the robot to move to its home position, and thereby avoiding the obstruction. So now let's look at offsets. Offsets are something that we're going to use fairly frequently in our vision course. So you'll want to have a good grasp of what offsets are and how they can be used. So in this example, let's look at how the offset is being applied. We have a position register where we're isolating just the single element. So if you remember, 3 represents the Z component of that position register. And we're making it equal to a register or a value stored in a register. So we're overriding the Z component of this position register. Now here in this line of code, we are moving to a point 1, and then we are offsetting that point by this position register. Now this doesn't overwrite point 1. Point 1 remains the same as it was earlier in the program, so it doesn't change. However, the position where the robot will move to will be a little bit different as a result of this offset. Now if we look over here in this position register, we notice that the registered value that was written to that position register was 500 for the Z component. The remaining elements were zeros. That means when we apply this offset, it's adding that offset to this position. So the only element that really gets added to that position is the Z component, because the rest of them were just zeros. Okay, I'm going to demonstrate how we can utilize position registers to offset the position of our robot as it cycles through a looped program. And so initially, I'm going to start with just my square program. So as it cycles through, just creates a square, and then and that's it. So now I'm going to go ahead and change that and modify that program to include a loop, as well as some position register offsets. Okay, so I've added a few more things to my program. I've added a counter that initializes at 0. I've also added in where I can increment my counter by 1 each time I loop through the program, and then a conditional statement to jump as soon as I reach the threshold of 3 cycles, as well as a jump label to loop me back up to the beginning. So now I'm going to add in a couple of offsets that illustrate how we can use an offset in a program like this. So I'm going to come down here and I'm going to initialize my offset value. Let's add in a couple more lines. Okay, so to insert my position register, I'm going to go into registers. I'm initializing my register, so I'm going to hit equals and then select my position register element instruction. And then select a constant of 0. Now down in each of my motion statements, I'm going to add in the position register offset, which is in the next fly up menu, position offset position register. So I'll select that and then select 2, and I'll do that for each one of those. All right, now I've got each of my motion instructions offset by that position register 2. So the next thing I still need to do is go over to my data registers, open up position registers, and I'm going to initialize my position register 2. So when initially bringing this up, you're going to have all asterisks, and so you can just go ahead and type in 0 for each one of those, like I just did there. And now when it adds the offset to those positions, since we're only going to be writing to the Z component of that position register, everything else will have no effect to that position. So now I'm going to come down into my program. And I'm going to decrement my position register by 50 millimeters. And then I'll insert one line just to break that up a little bit. Okay, so now let's go back up to the beginning of the program, run it, and see if we are able to offset our Z value each time we loop through the program. And then just to verify that everything initialized correctly, let's run it again and make sure it starts from the beginning. Okay, and there you have it. All right, now let's look at miscellaneous instructions. We got several instructions that we can use that are all underneath this miscellaneous tab in our menu. Some of the more common ones that we will use are timers, which we can use to track the length of an operation, and we can then refer to that time to trigger other operations, macros, or whatnot. We also have override, which sets the percentage speed of the robot. We also have a remark, which can allow us to add comments in the program, and this is different than the remark that we find through the edit command instructions on our teach pennant. This type of remark allows us to add just text within the program that isn't executable and is there just for the operator or programmer to refer to, and that gives some additional information about that section of the program. We also have a message instruction, which will allow us to display a message on the teach pennant. Again, this can be used as a way to alert the operator of something that they need to do or something that is going on with the robot that we want to draw attention to. All right, now we're going to look at some different miscellaneous functions that we can use with the robot. There were about 3 instructions, I think, that were covered in the 3 or 4 instructions that were covered in the manual. And just to look through those, so the first one that we can use, the first one that I would like to show is the remark function. So the remark function is a way that we can include information in our program that is going to be useful for the operator or the programmer who's going to be referring to the program. So let's go ahead and insert an instruction ahead of my register values. I'm going to go over to an instruction and then the miscellaneous menu here, and then pick remark. And then pick remark. You'll see that it comes up with a line that has an exclamation point and then a blank line. To edit it, I just hit enter. Allows me to type something in. And then newer controllers also highlighted in yellow, which is quite nice to make it more visual. So this is a line that won't be executable in terms of anything that the code will do with it. Is just there as a remark for our benefit. Okay, the next one is a timer. Timers can be utilized in order to record or monitor the length of time to perform a particular operation. So if I wanted to use the timer, I'll set it here at the beginning. I'm going to insert 2 lines. And then going to that same miscellaneous folder, you'll see a timer here. And we have the option of, I think it's about 10 different timers. And we have the option of using about 20 different timers. So I'm going to go ahead and select this as timer 1. And I'm going to select reset initially. You'll see why here in a minute. So my next one, I'll set another timer, and this time I'm going to set it as start. That means as it gets to this point, it's going to reset any information for that timer and then start it again. And then towards the end of my program, I'm going to put in another comment down here at the bottom, just after it finishes cycling. That's going to say, I'm going to pick the timer, select timer 1, and now I'll stop. Okay, so when we access the timer, going over here to my next screen, I'm going to select menu, go to the next page, and then from status, we have this program timer or system timer. These are program timers, so I'm going to select that. And now we can see where the timer value is stored. So at the end of the program, when it stops, it'll write the counter value or the timer value here. And that way I can keep that timer information until I decide to execute the program again, at which point it'll reset it before starting the program or before starting the timer. The next one that we learned about was messaging. So I'm going to go ahead over here in my program and insert 2 more lines. And then I'm going to create a message that just, so I'm going to create a message, and you see where it puts the message instruction on line 30 with a set of brackets with just a couple of dots in between. And so I'm going to go ahead and hit enter. Now that allows me to enter in a type of message that I would like to display. Okay, so now let's go up to the very beginning of the program and we can run it and see how everything works. So you can see here over on the right, the timer was counting. The process took 9.49 seconds. And then down here, we had at the end of our program, it pops up with a user screen that then says process is done. If we ever want to access those messages again, we just go to menu and then we select this user here, and that brings up the user screen where the messages are displayed. Those messages will remain there until I think it can hold a maximum of 10 messages. So beyond 10 messages, then it starts to overwrite them. So beyond 10 messages, then it just starts to overwrite them. If you want to clear out the messages, you actually have to come up with your own program, and I set mine up as a macro that then just puts in a bunch of blank messages to overwrite anything that's in the user screen. And then I set that up as my user key 3. Okay, so those are just some of the miscellaneous instructions that we can use, as well as some of the others. Feel free to play around with them, get an idea of how they would function, and you're welcome to search them up or ask me questions if you have any, or ask me questions on any of the instructions that you're curious about, would like to see how they work.